All right, welcome and good afternoon. In this hands on session, Brandon Carroll, a senior developer advocate at AWS, and Pierre Peterson, a senior solutions architect at MongoDB, will walk us through how to secure our Atlas workloads on AWS with PrivateLink and KMS. Please welcome Pierre and Brandon.
Hi guys, nice to be here again. Maybe I saw you some of you yesterday talking about client-side field level encryption, but today we're going to talk about that together with KMS and PrivateLink. So customers today that are using AWS and deploying workload on AWS want to also be secure when they use third-party services like MongoDB Atlas, and they have some concerns about that. So if you're running in a different VPC, your source service, how will you secure that? Yeah. We're going to talk about how PrivateLink can secure that. But then you have the data. How do we secure data in use and data privacy? Yeah. So we're going to dive deeper into those challenges and how we can actually use AWS services together with MongoDB client-side field level encryption to solve that. So securing your workloads, there are some challenges. So if you want to have private connectivity from your VPC to a third party, how do you do that? How do you do that if it's a third-party service? And how do you do that with low latency and fast access, network throughput? And also, when you have your data in a different cloud and you know that it's stored in a database it's not in a different VPC, how can you ensure that data is encrypted in a way that nobody can look at it? Yeah? You have the client key encryption keys. So we're going to talk all about these different topics and how we can actually implement this with AWS services and MongoDB's client-side field level encryption. So I will just run through agenda really quickly. We are going to focus on 3 parts here. The first part is the KMS, so using KMS to secure and encrypt data. And then we're going to talk about how we do that for network, how we secure the network traffic by unidirectionally and not bidirectionally using PrivateLink. And then we're going to talk about client-side field level encryption, how to use that to do that in memory. And this is going to be a demo-driven workshop, so it's not that much slides. We're going to actually show you how it's done, how to set up everything. So Brandon, you want to come up? And that was a short intro, but yeah, go ahead, Brandon.
Thank you. All right. So as Pierre mentioned, we want to start out talking about how to secure that connectivity. And so with AWS, we're going to use AWS PrivateLink. So PrivateLink is a way to connect to MongoDB Atlas. We'll be in one VPC, the customer VPC. I'll show you an architecture of this in just a moment. And then the MongoDB Atlas service will be in their VPC. And we're going to securely connect those through an interface endpoint, giving us private encrypted connectivity without sending that traffic over the internet. So we're going to keep it all in-house. So this is a one-way connection, so it's not an extension to the perceived network trust boundary. It's one way. It's also a whitelist model, and I'll show you that in the demo, how that works. And as far as performance, 10 gigabit per second availability zone, and then automatically scaling up to 40 gigabit per second. So it's fast, secure connectivity, and it's not sending your data over the internet. So this is what the architecture would look like. As I mentioned, on the left-hand side, we've got the customer VPC. So this would be your client. Your client would be the client side that's interacting with MongoDB Atlas. And so we'll generate a VPC endpoint. I'm going to show you how to do that in the demo. And then AWS PrivateLink makes use of that to connect into the service. Right? Now, let's just jump right in. I like to just get right into the actual code and the configuration of this. So let's see. OK. So here I'm logged into MongoDB Atlas. I'm looking at my database deployments. But I need to set the configuration up to start building that private link between the two. So what I do is I go to Network Access, and then over here, Private Endpoints, I'm going to add a private endpoint. Now, we're going to select AWS, of course. And then we'll click Next, and we need to pick a region. So AWS PrivateLink is a regional service. We're going to pick US East 1, the North Virginia region. And at the top, you can kind of see it spinning. It's creating the endpoint service on the Atlas side. And I need to get my VPC ID and my subnet ID. So I jump back over here to my EC2 instances, and I grab the VPC ID first. And this is the instance that's going to be interacting, right? So I drop that in, and then I come back over here, and I grab my subnet ID, and I drop that in. And at this point, it's still creating the endpoint service, but as soon as that endpoint service is created, as soon as that's brought up, I'm going to get the option to copy, and you can see that just happened down at the bottom. So now I can copy this AWS CLI command that has all the data I need to actually build that private link, that endpoint in my AWS console. So I'm going to copy that, and then I'm going to jump back over here. I'm going to actually use AWS Cloud9 because it's got a nice terminal that I can throw commands at my account with, my organization. I drop that command that I copied in, and it's now gone out to AWS through the AWS CLI, and it's created that endpoint. So I can see that in the console if I go look at the VPC service. And then on the left-hand side, I'm just going to scroll down, and I'm going to look for endpoints. So it's created that interface endpoint for me, and there you can see that it's created this endpoint. That's my endpoint ID. It doesn't have a name, but I can go ahead and click there, and I can add a name so that when I do come in here and look at it, I know what this endpoint's being used for. And then if I click into the VPC endpoint, I'm going to copy the endpoint ID because I need this bit of information to finish the configuration on the MongoDB side so that I get whitelisted. So I jump back over, I'll go ahead and click Next, and here's where I put that VPC endpoint ID. So I'll go ahead and drop that in, and then I'll click on Create, and it's going to go ahead and whitelist my connectivity, and you'll see down on the bottom the endpoint status, bottom right, it's finding the endpoint connection, it's going to go pending, and then it'll go available. And once it's available, I know it's ready on the MongoDB side, and I have sort of the same thing happening on the AWS side. So I'm going to jump back over here, and I'll just go back to endpoints. And you can see down at the very bottom middle, it still says pending acceptance, but if I click the refresh up here, now you can see down in the bottom middle, the status is available. So it's available, the private link is available on the AWS side. We know it's available on the MongoDB side. And now the next thing for me to do would be just to test that connectivity, see if I can talk. So I'm going to go back here to database, and I'm going to click on connect, and I'm going to use the MongoDB shell to do this. I've already installed that on my Cloud9 environment. So I'm going to say that I do have it installed, and I'm going to copy this connection string, and I'm just going to replace that username bit there with my username. So I'll come back over here to my Cloud9 environment. I'm going to drop that in, and I'm going to replace that little username bit with my actual username. And then I'll hit enter. I've got my password on the clipboard already, so I'm going to drop that in, and it's going to go ahead and connect. And it's connecting securely over my private link service. And then again, we'll just do a show databases and list the databases, just again, making sure we really do have connectivity over this private link from my client VPC, my customer VPC, into the MongoDB VPC where Atlas is at. So that's the connectivity part. So now I've established this connectivity. What's next? Well, when Pierre talked about the introduction, when he went through things we wanted to do, we wanted to secure the connectivity, and then we wanted to secure the data. And so here's how AWS is going to help to secure that data. What we're going to do is we're going to use the AWS Key Management Service. So this is a managed service that uses hardware service modules, FIPS 140-2, and it will generate a key with it, and I'll talk about how we're going to use that key. So here I have the AWS KMS service. KMS service gives me a couple different ways to manage my keys. So we can have encryption with different AWS services. It integrates with most services, so it can generate managed keys right from there. Or we can create our keys the way that we're going to do it here. So with KMS, I'm going to create an envelope key. Now, you might see this called a master key or a KMS key, but this is the envelope key. And then what's going to happen is you'll see when Pierre does the demo, he's going to take and generate a data key and use that data key to encrypt something that's in plain text, right? Some field, some data that we want to protect or we want to hide. So he's going to encrypt that, and that'll create the ciphertext, right? That's just the basic encryption process. But what AWS is going to do is we're going to take that data key and we're going to encrypt the data key with the envelope key. And then when we send that data, we send them together. So they can live together. The data is encrypted, same encryption standards. So we're not concerned about that data key being used. And the only way to be able to decrypt that data key to then decrypt the data is to have access to that KMS key, that envelope key, that only lives in KMS. It doesn't leave KMS. And so you can interact with that as long as you're allowed. So let me slide that over, and let's talk about how we know who gets access and who can use that KMS key. And the way that works is with AWS IAM, Identity and Access Management. So we have a combination of IAM policies and an IAM role, and that's going to give you the ability to have short-lived access to the key. All right, so this is really important. We're not taking security keys that are static and using them over and over to be able to gain programmatic access to the key, to be able to use that API. We're using a short-lived token. Right, it's like 15 minutes or less while that thing is usable. Okay? And so Pierre's going to demonstrate, in his example, changing to the role and accessing the key. So let's look at what it looks like to set this up. And so, again, I'll jump back in. I'll start out here in Cloud9. We're going to do a little bit on the terminal. I'm going to stick to code because that's more fun. We'll just do some shell scripts and some AWS CLI, but I want to go over to the endpoints VPC tab again here, my console, and I'm going to go to KMS. And I'm just going to show you, I have a couple of keys that I created just in testing, but I'm going to click Create Key, and you can choose from here. Is it a symmetric key? Are you going to use it to encrypt and decrypt? Where's the key material come from? Is it single region? Is it multi-region? So you get to define this, and then you can kind of go next and set permissions and do all of that right in the console. But let's do it through code. All right? So what I've done is I've copied a GitHub repo. I've pulled it in already. And it's telling me in the README here, I've got two scripts. I got a KMS master key and an IAM role script that I'm going to run. And if I go into the AWS CLI, here's my KMS shell script. All it does is sets the region and then plugs that into an AWS KMS command to create the key. And then that grade portion is just an example of what the output will look like on the CLI if it's successful. So let's go ahead and cd into that directory. And let's run that script, and let's get it to generate a key for me, an envelope key in KMS. So I run it, there was the output, and then when I jump back over, there's the new key. So you saw before I only had the two, here's the new one, and it's enabled. And so I'm going to go in and I'll copy this key. I'm going to need that information for one of the scripts that I'm using to populate a JSON file that we're going to reference. So when I come back over here, I go into my IAM shell script, and up at the top it tells me there's two things I need to do. There's two JSON files. I need to put my account ID, and I need to put my KMS master key in another, not the actual key itself, just the ID of the key. And so that's what I'm doing. I'm going to go into my role policy here, and I'm going to drop that master key in. And then I need to go Command S will save it, but I also need my account ID in that same JSON file. So I'm going to come over to my console, and I'm going to copy the account ID from the top right there. And I'll just replace it again here. And again, Command S, Control S, We'll save it. Then I'm going to go into the role trust policy. This is to create that policy for the IAM role. And I'm going to put my account ID in there as well. So now I can run this IAM shell script. It's going to run an AWS CLI command to create a role for me called MongoDB client-side encryption, and then it's going to plug in the role trust policy using those details from that JSON file. And so I'll go ahead and run that script, again, interacting with my AWS account. And then if I come back over here in my console and we go to IAM, I look at my roles, and I can just do a quick search. There's the MongoDB client-side encryption role that I created. And when I come down, here's the policy. And this policy is saying that I can decrypt, encrypt, and so on. The functions that I need to be able to do if I have that role when we do the encryption. All right, so that's the configuration of both PrivateLink and building that envelope key in KMS. As far as the cost goes for the KMS portion, that'll take you to the pricing page for KMS. It's a pretty simple pricing. Each KMS key that you create is $1 a month. If you enable automatic key rotation as you generate that new backing key, that costs $1 per month. And then as far as the API calls to use it, the cost is going to depend on the region. So this is if you're outside the free tier, there is a free tier. So depending on the region, the cost will vary, but that link will get you to it and have all those answers for you. So with that, I'll invite Pierre back up, and he'll talk you through the encryption side of it, the client side.
Thanks, Brandon. Yeah, so let's talk about, now we have created a key, we have created a private link. How can we use AWS KMS together with client field level encryption? So let's talk about what that is. Maybe some of you know what it is, but let's just recap. So the design goals of client-side field encryption is to provide the most security and data privacy for your regulated workloads. So this means if you have sensitive workloads and you want to ensure that you have the highest security posture, you can do that with client-side field level encryption. So it's to provide end-to-end encryption, but it's also to be able to increase your confidence level when you're moving to the cloud. Because if you're encrypting the data on the client side, your cloud provider will not know what's actually stored in the cloud, yeah, because you have the key. It's encrypted before it's sent to the database. And then we have also GDPR. In Europe, we have a requirement that you need to be forgotten if a customer is off-boarded. So if you have a contract with a phone company and you want to cancel that, yeah. In Europe, you need to be able to remove that customer data, everything about the customer, not just in the database, but also in the logs, in the backups. So with GDPR, you can shred the key, you shred the encryption key, and then you're losing the ability to actually read the data, yeah? So encryption is proven, but there are actually gaps, yeah? And this is what I'm going to talk about when you're using client-side field level encryption. So if we look at what we have today, we have TLS enabled. So when you have TLS enabled, that means that when the data is in flight, you actually use TLS encryption to secure that data. About what network then? So when you have the data stored at disk, how do you do that? At rest, then you have volume encryption, bring your own key you can do, or you have storage encryption. But as soon as the data is read up into memory in use, it's in clear text, yes? You can actually read that data. So what we're trying to solve with client-side field level encryption is actually solve that issue. So when we have the data in clear text, how can we make that even more secure? Because if it's in clear text, you have the vulnerability of doing process scraping or RAM scraping to be able to dump that data. So let's go through the next one here. Is it not working? Okay, I will do it like this. Seems like so no database actually offers a standard solution to do that, but MongoDB has client-side field level encryption. But let's look at how you can do it if you don't have client-side field level encryption. How would you do it, if you build it yourself? You can do something like application level encryption, and this means that you're encrypting your sensitive data. So if you have 3 sensitive fields like social security number, email, and mobile, you will use some application logic to encrypt those fields. cluttering down your code, and there are other challenges with it. You need to implement that code and change your code. So an insert statement that has encrypted field will not look the same that doesn't have that. Yeah, it will be two different ways of doing it. And then you encrypt the data, and then you store that, before it's sent to the database. So you're encrypting it before it's sent to the database, and it's stored in ciphertext. So what are those challenges doing that? It's highly complex if you want to implement application-level encryption. We have actually seen 50% overhead in doing this because you need to have cryptographic expertise, and also how you're going to manage the keys. How are you going to ensure that the right key is chosen, decryption, encryption, and such. But there are other aspects also that's important here. You cannot query the data. Maybe you heard about that. We just released queryable encryption, which means that we can actually query encrypted data, yes? If you do application-level encryption, you're encrypting the field, and it's just a blob store, yeah? It's a DOM. You cannot do equality matches on it. So you're actually not be able to query the data that you want to query the way you want to. The other thing is that you probably need to add application logic code to encrypt and decrypt the fields. And that also will affect your performance, yeah? If you're cluttering down your code with additional lines of code, that will make it not that performant, and then you have bad user experience. So what can you do? You can either do nothing, just keep it as it is. It doesn't work, no. So don't do anything. Don't use application-level encryption, but then you have the risk of the data being exploited. And when the data being exploited, you can be suffering from a data breach, yes? Or you can actually add application-level encryption. This is what I talked about, implement it on your own. But that adds huge complexity and friction in your development process. You have seen. So none of these options are really good options, yeah? So what MongoDB offers you is client-side field encryption. It's a much safer and simpler approach. So what you do, you just select an encryption key, and we will use the KMS key here as an envelope key, and then we'll create a data key that will be used to encrypt the fields. And then you're ready to go. And this is totally decoupled from your application logic today. So if you're not using client-side field encryption today, you can just enable this, yeah? By enabling this, you don't do any code changes in your application and still have this capability. This is really important to remember. And the data that leaves the application is always encrypted, yeah? So you encrypt on the client side, and you can ensure that the data remains encrypted on the backend side. You don't need the modified application, as I said, and the data, this is really important, yeah? The data is still queryable. So if you use deterministic matching algorithm, it will mean that you can actually do equality matches, yeah? And with our new functionality with the queryable engine encryption, you can actually do prefix matching also and range. And this, because we have optimized the MongoDB driver, this means that you don't have to think about it, yeah? We have optimized it, which gives you the best performance that we can give. And the most important thing, what we were trying to do with MongoDB for you as a developer is to reduce your cognitive load so you can focus on what's important, building business value, not the nitty-gritty technical details. So now I'm going to the demo, the fun part. Let's get going here. So what I will do is I will use the same project that Brandon did, and we're going to follow the steps. The first step is to configure your AWS KMS provider, yeah? And we are going to use the KMS key that Brandon created, the envelope key. But before we can do that, this is the project. If you want to look at that, there is a GitHub repository you can reuse. But before we can use the key, we need to actually get access to it, yeah? So we need to actually use temporary access token, short-lived tokens to be able to get the KMS key. So what I'm doing here is assuming a role, and then I'm returning the access key and secret access key and the session token. This is a short-lived token, remember, important. It's not the hard-coded access key here. It's a short-lived token that I will use to be able to connect to the KMS API to get the key, yeah? And then I'm using that here in the KMS provider configuration. I'm also providing a key vault. When you create a data key in MongoDB, the data key is stored in a collection in MongoDB that's encrypted by the envelope key. And this is the name, the demo database and the key store where the data keys will be stored. So let's do that. Let's create the key. I'm just showing here what I'm doing here. So I'm connecting with the Mongo client. And then I'm using the KMS provider to be able to connect to the KMS API. And then I'm doing the client configuration to be able to connect to MongoDB using client-side field-level encryption. And then I'm using the create data key here. And that will then create a data key in the collection that I just provided. That's the key store collection, yeah? So let's run this, see what happens. So this is Node.js application I'm running. Yeah, and it will generate, as you can see, the key ID here. And of course, you can do this many different ways. This is just for demo purposes. I'm doing it step by step, so it's easy to follow, yeah? So if we go to MongoDB Compass now, we can see that in the key store, we actually created the data key here. And this is the key I will use then to encrypt the different fields, yeah? And that will we do next year. Yeah. So we can see that it says created that. So let's go back to the schema here, and we need to create the JSON schema. So we have created the actual key. We have set up the KMS provider, but now we need to also define a JSON schema. And the JSON schema will then be used by the MongoDB driver to understand which fields it needs to encrypt or decrypt, yeah? So let's look at that. So if I go to the file here, yeah, you can see here I have a schema. I'm defining a demo person. This means that we have the database demo and the collection person. In that, we are saying that we have an object, a document, and we want to encrypt the field called credit card, because we are using encrypt keyword here. By using the encrypt keyword, the MongoDB driver will understand that these fields need to be encrypted. And then we're also providing the key ID here. And the key ID will be sent into this function and create that JSON schema, yeah? So let's do that and run the query. So now we'll put this all together and execute the query. We have the KMS provider, the schema, the data key, and such. So I'm copying the data key to the main method here, which actually running then inserts to the collection. So you can see the JSON schema here. We went through. I will just provide that key. And then we actually could run this, actually. So let's do that. I will also go through, so we can see that we are using the Mongo client here and providing the key vault namespace, the KMS provider, all of this configuration that we just did, yes? This is the stuff that we just configured before. So let's run this. And I'm then doing an insert also here, as you can see. I'm doing a secure client and then doing an insert. And you can see this is the same thing you would do if you didn't have a client-side field of encryption enabled. So it's the same insert, same find statements. It's nothing different from what you would do if you didn't have it. And this is really important. It doesn't clutter down your code, yes? It doesn't require you to do any code changes. Now running an insert here, running this program, and that will then create a document in the database. Let's look at that and see how it looks. So yeah, here we have the actual person collection, and we can see it's actually encrypted the credit card using the KMS and the data envelope key. Yeah, that's that. I think that. Let's go to next. Yeah, so to wrap up, I don't know if we have time for questions, but so what we want to take away from this is that you can use AWS services to secure your Atlas workloads, yes? And you can do that by using AWS PrivateLink, AWS IAM, and client-side field of encryption to be able to do that. And then you can be sure that you can deploy third-party services, not just Atlas, it could be other services also that third party. Yeah.
Thank you. We have time for one question from the audience.
Brandon, you want to come up? Maybe it's...
Hello. Thank you for the presentation. It was really good. My question is, I know that Atlas allows you to set the KMS key for data at rest. My
Yes.
question is, setting your own KMS key for encryption at rest, is it a best practice or actually doesn't matter?
I think it depends, but some customers don't use it. Some customers want to use it to be ensure, even if you look at the Cloud Act, you know, there is like a concern about the Cloud Act, and some people want to use it. And I won't say it's everyone. I don't know, do you have any comment on that?
No, it's the same
No,
thing.
I think it depends. It's a depends question, yeah. But I would say if you have data that's really sensitive, then maybe you should bring your own key, yeah? Provide your own KMS key. That's what I would say.